Okay, section 14.2, we're going to be proving trigonometric identities. And so here's the deal. To prove an identity, you can work on one side only. One side only. So you're going to work on one side. One side only. And you'll keep rewriting it until it becomes the other. So you're going to transform it into the other side. When you work on a side, you want to choose the more complicated side. It's easier with math anyway, to take something more complicated and make it look more simple. Much different from real life, right? In real life, it's easy to make a mess of things, right? But and harder to clean it up. But with math, it's easier to take something that looks more complicated and simplify it. So, and then you want to make sure that you show all of your steps, because here's the deal. These are identities. I'm telling you the left side is equal to the right-hand side. So I've given you the answer. Proving an identity means that you're showing me every step in the middle there that shows that it's true. So you got to make sure you show all steps. All right, so let's prove that 1 plus cosine of x times 1 minus cosine of x is equal to sine squared. All right, so like I said, you're going to work on one side only. Even though this is an identity, it's an equation, you're not allowed to work on both sides of the equation. You're not allowed to add something to both sides or multiply something by both sides or anything like that. You're going to choose one side and just keep rewriting it until you get it to look like the other. All right, so definitely this left-hand side looks more complicated for sure. So that's what I'm going to start with. I'm going to start with this guy and what to do. Well, the only thing you really can do right now is let's multiply these guys together, right? So foiling it out, 1 times 1 is 1. Outer and outer is a minus cosine of x. Inner and inner is a positive cosine times 1. And then last times last would be a minus cosine squared. The middle guys cancel. And you're left with 1 minus cosine squared. Now, keep in mind, you should always be looking at what your goal is. My goal is to get sine squared. Well, what the heck? How do I get sine squared from this? Well, it's actually equal already. And how? Well, since we have that Pythagorean identity of cosine squared plus sine squared is equal to 1. And remember I said, okay, that's the identity you're going to memorize, but keep in mind you can rearrange this equation and it will be the same thing. So what happens if I subtract cosine squared from both sides? Well, sine squared is equal to 1 minus cosine squared. And there you go. Sine squared. Yay, done. All right, so you have taken the left-hand side and you have transformed it into the right. You just proved this identity, showing every step. And then, I even wrote this over here. All right, so let's do another one. How about let's prove that cotangent of x plus tangent of x is equal to cosecant of x times secant of x. Now, it is easier. So you look at this, I look at that, and I'm like, okay, neither one of them looks more complicated than the other. They both look pretty complicated, right? But here's a hint, is that it's easier to transform addition or subtraction to multiplication or division. Okay, it's easier to take the left-hand side here. It's easier to make, since this has a trig function plus another trig function equals a trig function times a trig function. I'm not saying that you can't start on the right and get it to look like what it does on the left, but it will be harder. It will be more difficult. It is easier to turn a plus sign into a multiplication. So I am definitely going to start with the left-hand side and keep rewriting it until it looks like the right-hand side. So I'm going to start with cotangent of x plus tangent of x. And I look at that and I go, well, how am I supposed to do that? How am I supposed to get this equal to cosecant and secant? It's none of the identities. I didn't have an identity that cotangent plus tangent was equal to anything. So when in doubt, right? But this should be your last step, right? Your last resort is if you don't see a Pythagorean identity or something very obvious, then turn things into cosines and sines. Yeah. So cotangent is cosine over sine. That's an identity. And tangent is sine over cosine. Okay. I still don't have what I need, but I'll get there. The only thing you can do now is add these two fractions together. And to do that, you need a common denominator. So I would multiply this first fraction by cosine over cosine. And I would multiply the second one by sine over sine. Like that. So that I end up with a cosine squared plus sine squared over cosine times sine, cosine times sine. Okay, yay. You're like, what? I don't see anything yet, Mrs. Bright. Okay, that's all right. That's normal. Yeah, it's very normal to feel like you are in a very dark tunnel where you don't see what's happening at all. I call it the trig tunnel. And it takes practice. And the more you practice, the better you'll get at it. And then it won't feel so dark. It might feel dark in the beginning, but you'll end up seeing a light. All right. I know cosine squared plus sine squared. That's a Pythagorean identity. That is 1 over cosine of x, sine of x. Is cosine squared plus sine squared, since the Pythagorean identity says cosine squared plus sine squared is equal to 1. That's a Pythagorean identity. So I replaced the top with 1. And then you want to always keep looking at what is your goal, right? What is your end goal? I need cosecant times secant. And right now I have 1 over cosine times sine. And you're like, what? How do I get that? You actually have it, right? I'll show you that do you remember that when you multiply fractions together, you multiply top times top and bottom times bottom? So I'll show this step, not that it's necessary, but do you see that if you were to multiply these two fractions together, 1 times 1 would give you 1, and cosine times sine would give you cosine times sine. Yeah. And what's 1 over cosine? It's secant. And what's 1 over sine? Cosecant. Yeah. And this is, what do I need? Oh, well, that's the multiplicative commutative property, right? 2 times 3 is 3 times 2. So this is equivalent to cosecant of x times secant of x. Check. Yay. All right. Okay. Let's do another one. Okay. Let's see here. We're going to prove that sine of x over 1 plus cosine of x is equal to 1 minus cosine of x over sine of x. Okay. So they both look just as complicated, right? Not one doesn't look more complicated than the other. But here's another hint that when you having this right-hand side has just a single term in the denominator versus this one has 2 terms in the denominator. So the left-hand side is more complicated. It's easier to simplify this than it is to get this is more simplified than that. I know that sounds weird, but it's because of you've got a binomial in the bottom. You've got 2 terms that are in the denominator there. Okay, so what am I going to do to get that? And you're like, I have no idea, Mrs. Bright. I don't blame you. It's okay because you're just learning, right? But here is a trick that will work a lot. If this had been, I see a 1 and I see a cosine down there. And I know there's a Pythagorean identity involving cosines and 1s and sines, right? But the Pythagorean identity is that sine squared plus cosine squared is 1. So it's not quite this. I would need squareds on these and I would need a minus sign there. So here's the trick. The trick is multiply by the conjugate of the denominator. If you see a 1 plus cosine or a 1 minus cosine or a 1 plus sine or a 1 minus sine where there's not squareds there, multiply by the conjugate. And you can do that as long as you multiply the top by the same thing, because now you're just multiplying by a fancy looking 1. Okay. Here's another hint is don't distribute this top. Leave it factored out at first. You may end up needing to go ahead and distributing it, but in the beginning, leave it factored like this because a lot of times it will end up canceling with something in the bottom, and then you'd have to factor it back out. So just leave it factored for now. 1 plus cosine times 1 minus cosine. That's a plus b times a minus b. Do you remember that? That a plus b times a minus b ends up being the difference of two squares. It's a squared minus b squared. All right, so what becomes of this? It's 1 squared minus cosine squared. Yeah? Okay. Well, what happens there? Well, this is 1 minus cosine squared. 1 minus cosine squared is how we would write that. That's a Pythagorean identity. Remember, the Pythagorean identity says that sine squared plus cosine squared is equal to 1. And if you subtract cosine squared from both sides, you're left with sine squared. We already did that in a different problem, right? Okay, so that means I've got sine of x times 1 minus cosine of x divided by sine squared. Keep your eye on the prize. What do I have compared to what do I need? Well, I got a 1 minus cosine up top. Oh, look, I have a 1 minus cosine up top. I have a sine in the bottom. Oh, I have 2 sines in the bottom. But do you see there's a sine up top? And this sine up top will cancel with just one of the sines in the bottom. And you're left with 1 minus cosine of x over sine of x, which is what you wanted to prove. Yay! All right. Listen, I know these are tough. I know you're probably looking at this going, oh my gosh, how am I supposed to do this? It takes practice. It takes practice. It takes, yeah. All right, let's do one more. If you don't practice it, and if you don't have those things memorized, then you're going to really have a problem because you'll just be staring at this and then you'll just start crying. You'll throw your head down. You'll be like, oh my gosh, I can't do this. There's no way. It's impossible. But I'm telling you right now, it's not impossible. You can do it. Okay, you're all smarties. All right, which side looks more complicated? Well, I don't know about you, but I think this one's an obvious one. Some of the other ones may not have been obvious, but this one, definitely. Left-hand side is definitely more complicated looking. And so I'll start with this guy. And, oh, you see what you could do? Not obvious. How the heck are you supposed to turn it into cosecant? Can I get rid of these guys? Not that I can see right off the top of my head. So here's what I'm going to do. When in doubt, and I don't have anything else, then I will turn things that aren't cosines and sines, and I'll turn them into cosines or sines. So cosecant is the reciprocal of sine. So this is 1 over sine times cosine squared. All right. Well, that becomes a cosine squared over sine, because you would multiply, like this is like over 1. You would multiply these guys, but then you've got plus sine. and that's like a sine over 1. And how you add fractions is you need a common denominator, so I multiply top and bottom by sine. So that you've got up top here a cosine squared plus sine squared all over sine. And do you see it? Are you blinded by the light? This is my analogy. I say when you're doing these and you first start a problem, you are in a dark tunnel that is pitch black. You don't see anything, right? You have no clue what's going on. And it's very scary in the dark, right? And I'm hoping you will get to the point where the more practice you get, you'll end up like you're working along, and all of a sudden you'll see a little glimmer, just a little glimmer of light at the end of that trig tunnel. And then hopefully, right, you'll see like, oh, is that something? Maybe. And then it'll end up being so bright, right? That light at the end of the tunnel becomes so bright that you are able to see what's about to happen. And you get to the point where you're blinded by the light. And I can sing you the song. You go, blinded by the light. Wrapped up like a deuce, another runner in the night. It's a very old song. Hopefully you know it because your parents have listened to it. But cosine squared plus sine squared, that's a Pythagorean identity. That's 1. So you've got 1 over sine of theta. Are you blinded now? Blinded? So blinded you need sunglasses on? I hope so. 1 over sine is cosecant. Doo, doo, doo. I'll tell you what, I love these identities. Math was never my favorite subject in school. I was always good at it, but never my favorite. I loved trig, and part of that was because of these identities. I love a puzzle that is a struggle at first, but when you can struggle your way through it and figure it out, it's just so satisfying. So I love these. All right, so here's some strategies that I used. First of all, you're going to choose the more complicated side. Again, it's easier to simplify a complicated side than to take a nice, neat package and then mess it all up in math anyway. Make sure you keep your eye on your goal. Keep looking at where am I heading? Like, what do I need it to equal? Because you may already get it there. You'd be surprised at how many students will go, I call it going around the mulberry bush. You'll actually reach like one step from your answer. I'll be like, oh, all you got to do is just rewrite that, like right here. And then students will go and do some crazy stuff to this. And I'm like, you were right there. And you'll go around and you'll end up with what you started with. It's craziness. Okay, so make sure you keep your eye on the goal to make sure that when you reach it, you know you've reached it. Also keep a good eraser because yeah, look, even me, there's times where I've started these and I thought that I had a good strategy and I was rewriting it and maybe it doesn't work, right? So sometimes you just got to erase and start over. Some other strategies I used, I multiplied by a fancy 1. That was when I multiplied the top and bottom of a fraction by the same value. You can do that. You might want to multiply by the conjugate, which will get you the difference of 2 squares, which might end up being a Pythagorean identity. That's the only reason why you would want to do it, is if you can get the Pythagorean identity by multiplying by the conjugate. And don't jump to this one, because if you can get it to be a Pythagorean identity, your steps will be a lot less work. It'll be way less complicated to get to prove it. But when you don't see where you can get a Pythagorean identity from anything, then rewrite everything in terms of sine and cosine. You don't want to do that first, because you could make something way more complicated than it needs to be, especially if it's already so close to being a Pythagorean identity. It's easier to change that. But when you don't have any other choice, then sine and cosine will work. All right, I hope you guys are having a fantabulous day. Bye.